Okay. First of all, I'd like to welcome the folks that are here in the room and all the people that will be catching the replay on this presentation through Camtasia and our server, our web server. It's kind of an interesting moment for me in that this is the opening session of my farewell tour in biology of fishes. Most of you know that already. I'm William Neal, Bill Neal, teaching this course, the biology of fishes, both undergraduate and the graduate versions stacked together, as we put it, for the last time. I expect to teach it. I'm hoping that I can convince somebody else, like my former student and good friend Ray Camps over here, to step up and continue promoting and developing this approach. So, let me introduce some folks that aren't here so that you will start to get to know them. The first of these is Ashley. I knew her as Ashley Hannah, but she's recently married, and she's now Ashley Larimore. And that's her email address that she would like you to communicate. And I will send out a message to all hands. Come on in. I will send out a message to everybody in the class, letting you know that that is the email address she would prefer. Her Neo address is not working for some reason. I'm really glad to have Ashley helping with the course. She has agreed to step up and take responsibility for working with the graduate students in 617, both local and distant. She was my TA the last two occasions when I taught this course, and she is outstanding. But I don't want to sell this guy short either. He's Donovan Patterson. Some of you local folks know Donovan. He's a graduate student currently working with Dr. Gatlin. He took this course last time I offered it. So I've actually got two people assisting. Donovan will be the go-to guy here with the local group in the lab in Nagel Hall 110. He will also be responsible for reviewing the reports that are generated by 417 students, both the ones here in the room as well as an equal-sized group who are taking this course as a web access course because they had a conflict and couldn't be here. And I'm glad we have an alternative, because you can see, or you who are here can see, those who aren't here can see in your mind's eye, that we have a full house. I mean, I count 16 people in addition to Ray here in the room. And I'm told we only have 14 working computers, 14 Windows computers, which are what we're going to need to do the labs. So some of you, I'm hoping, might be able to bring your own, and I think a couple of you have agreed to do that. And that way we'll be good. Actually, we have a couple of computers that aren't working at the moment, but I think we can make them work. In fact, I think this machine right here, the one that's nearest my podium, is a working computer. I don't use it. I use my own rig here, as those of you in the classroom can see. So anyhow, the deal is that I will stand and deliver most Tuesdays and Thursdays. I will be regularly in lab on Tuesdays. Donovan will be here on Tuesdays in lab, in the physical local lab. In some cases, pretty much in charge. In other cases, helping me. And then Ashley lives in Houston, has a full-time job. So she's going to be working at a distance and mostly after hours, advising and grading people who are graduate students in the course. Not to say the graduate students can't get help from me or Donovan. They can. Or Ray. Ray will probably be here. We'll get him to help us too. But that's the division of labor that I've decided is best. Ashley is a former student of Dr. John Gold's. Some of you know Dr. Gold. He's a geneticist. She graduated in May, and so she's not even a student now. But we brought her back, for one more time. Here I am. For those who aren't in the room and can't see me there, I've got my cap off, but I've got it on here. I normally wear it because I like to avoid the bright lights overhead. They sort of interfere with my vision, being that it isn't that great anyhow. So I've taken to wearing a cap all the time these days, Ray. I think I'm standing on Corpus Christi Bay down in near Flower Bluff there, near the Packard Channel. Here's another photo, and I guess I want to show you a fish at some point. How many people here can identify that one? Let me see what we got. Those of you at a distance can be guessing now as we wait for this recognition on the part of local students. Of course, they're bashful. They don't want to commit a systematics error right off the bat here. That picture was shot down on the Sea of Cortez near the southern tip of Baja. And the fish there is a member of the family Carangidae. It's a yellowtail. Very important fish in the Indo-Pacific for sport. And nowadays there's a lot of interest in growing these things and culture. So this is one of those species, that sort of is at the interface between wild crop fisheries and fish culture. Not a real fighter, but really makes a nice fillet. A little, lemon and butter, and pretty swavery. That's a word I just learned on TV a couple of days ago. A little joke in that for those who might watch TV. I'll leave you to communicate with your friends and find out what the joke is. So, I don't often indulge in going out, and I used to do a lot more than that than I do now. But I've kind of made a transition from going out and getting a fish smell on my hands and getting seasick to doing a lot more stuff with simulation modeling. And that's a good thing, believe it or not, for you, because it makes it possible for you to have a much more substantial engagement with the topic than you could have if we didn't have this technology. And I'm going to let Ray Kemps, as we go along here, he's going to sit in with us from time to time. He did it the old way. In fact, Ray took the course, I guess. You must have, right, Ray? And
I
never took the course, but you TA'd it and got his degree. I checked just to be sure in '96. So it's been a while. And Ray's exposure to fish biology predates the transition to automation and simulation. Although he came in right at the beginning of what we call distance education, which really means technology facilitated instruction, and that's useful at a distance, but you're going to find out, those of you here in the room, that it's also very useful. If you'd catch the door, please. It's also very useful to people who are local. Come on in, just find a chair. You can sit right there if you'd like, or you can squeeze up here. So, I guess maybe I ought to say a little bit about my own background. As I indicated at the beginning, I'm sort of at the end of a career in fisheries and fish biology. I started out about over 40 years ago, and I did my doctorate at the University of Wisconsin in Madison, working on ecological impacts of heated effluent discharge on fish communities, and doing a lot of lab work, exploring the mechanisms involved in the responses of fish ecologically to the heated effluents. Went from there to the National Marine Fisheries Service in Honolulu and worked with tunas for 3 years. And then decided that the best place was back here on the mainland and came to Texas January 1, 1975, and I've been here ever since. So that gives you sort of the chronology. My interest is at the interface between the physiology and the behavior and the ecology of fishes. And in particular, what I would call aut-ecology. That's an old word, a very good word, but not often used anymore, to be contrasted with synecology. Aut-ecology has to do with the ecology of the individual organism, its responses to its immediate environment and its past environment, and its prospects for future environment. All of those things are involved in aut-ecology. Synecology, on the other hand, is at the higher level of organization than the individual animal. It's at the level of groups of animals, starting with the cohort, which is a fancy word meaning other individuals of the same age group and same species, and then going on from there to population biology, ecology, and community ecology. So we're sort of climbing the ladder here to the fields where people like Dr. Gelwick and Dr. Weinmiller work. And of course, somewhere along the way, adaptation from generation to generation gets involved, and that takes us into the whole realm of evolutionary biology. I don't deal much with evolutionary biology. I'm pretty focused on the individual organism, given its genome, given its equipment. I'm very interested, though, in how individual animals can change in an adaptive way to respond to present environment and to anticipate future environment. And it's those things that I want to, focus on here and give you the benefit of my experience and my effort to make sense of it all. And not all of it makes sense, to me or anybody else. Some of you will help it all make sense down the road, I hope. We'd like to... let me say another thing that I thought about this morning. This is not, a social club. But at the same time, I always encourage a spirit of community. Ray will attest to that. And I'd like you to get to know me. I'd like to get to know you, what interests you, what motivates you. I'd like you to get to know each other. To the extent that you want to. I don't demand it. What I do demand is that you focus on ideas and understanding ideas, that I will lay out for you. And try to stimulate you to think about. I will encourage you to think analytically, to think synthetically. By that I mean putting together all the parts, not just within biology of fishes, but using biology of fishes as sort of an interface with all the things that you know, both at lower levels like chemistry and physics and math, and working up to those higher levels, population biology and community ecology. So I invite you, if you'd like, to submit a head and shoulders small size JPEG image like mine there with holding the fish, whatever turns you on, and a little bit of an intro, either written that I can read into the record, or better yet, something that you generate that I will play into the record using audio recorder, a little sound recorder, that's part of Microsoft. It's on your computer. That only allows 1 minute, and that's good because, we don't want to take a lot of time for that, but we would like to have a chance for people both in the room with you and people who are outside this room to get to know you. Maybe this is a good time to say that, this is the tip of the iceberg, and I wouldn't say that 90% of it's underwater, but there's a lot of folks that are involved who aren't here today. This class has, last time I looked, 31 people officially registered. And in addition to Ray Camps here in the room, there's 10 more people who are participating at a distance, monitoring the course. I'm looking around. I thought I saw Melissa. Am I missing you, Melissa? I thought I saw Melissa sitting out in the hall, one of Dr. John Gold's students, a graduate student, Melissa Jurissi, and Elise, who is a technician working with Dr. Gold, an honors graduate of this program, but she's now working as a technician, trying to decide what to do next. Both those people are monitoring the course. And I suspect that's, as I indicated, mainly because they heard good things about it from Ashley, who was their buddy in Gold's lab. And in addition to those people, there's at least 8 people with Texas Parks and Wildlife Department participating at various levels of engagement in the course. All, I think, with coastal fisheries. And the reason for that is that one of my favorite colleagues and former students is Dr. Robert Vega, who heads up the coastal fisheries program in stock enhancement and hatcheries, marine hatcheries. He's responsible for Sea Center, Texas, and the Perry-R Bass Research Facility operation, the part that has to do with hatcheries, and then the Marine Development Center in Corpus. And so, that's another reason for you who are interested in fish and fisheries and maybe getting a job at some point to, get to be somebody that people know. And I think the next slide says that if you haven't sent me an email, or even if you have, there's my email address. I'm going to get to the greetings message that I sent out in advance of the class and talk a little bit about that. And in that email, I ask that you let me know that you had actually seen it and read it. About half, maybe a few more than half the people who are formally registered for the course, and about half those who are monitoring as professional courtesy audits, Parks and Wildlife folks mainly, have responded. I'd like to hear from the rest of you. I want to make sure that the email I sent out just didn't fall off the edge of the earth. Some of you have said you really prefer a different address than the one that the university uses for you, the NEO address. And I'm good with that. I'm adding those alternate addresses into my file. And what I do is, I feel an obligation to make sure I communicate the official, with you in an official context to the email address that the university recognizes. I don't want anybody to say, I didn't get the email because you didn't send it to NEO. But at the same time, if you tell me you got a Gmail or a Yahoo or some other personal account you check more frequently and would rather look at, I'll put that one in there too. So you'll get it both places. I want to address this last issue here. So that we can construct a group list. Well, I'm going to construct the group list, but I'm a little bit unsure about the sharing part. I don't want to infringe on anybody's security or privacy. I assume that if you don't want people to know your actual name, you use some alias in your NEO name. A lot of people do. I can tell by looking at it, some people I know who they are, but other people I can't really know unless they send me an email back or unless I see some connection. So everybody's going to see that first email, and I want to take you to that. I've got it up there, I think. There's all your names, and you can scroll around and see the names of the formally registered people in the course. This one would not include the professional courtesy audits, though, Ray. I sent them a little different email, but I think I copied this email to all those people. Did I not? So you've seen it. And there are the names, but I don't for sure know who Herp Major is. I might be able to guess. But, I probably, on the other hand, can guess exactly who T. Kruger is. Is T. Kruger here? Yeah, there you go. So I guess if you didn't want people to know what your full name was, you wouldn't put it up that way on NEO. But I'm going to leave it up to you to, send out emails to the group or to people you recognize and say, hey, that's me. You want to talk about this course, let's talk. If you want to communicate, collaborate, then you can do it. Here we are on the 28th of August, burning clock already, 30 minutes into the session. But, there's some important things I don't want you to miss. If you haven't read this email, you need to do so. You need to realize that Anna Manga there, Ashley, that email doesn't work right now. It may work next week, but she hasn't been able to reestablish her net ID. But the one that does work is fishbyota@gmail.com. So you need to communicate with Ashley there. This identity is good for Donovan, I think. You need to look at this. We're going to all be working hard. Not a social club. Rooting for the Aggies and rooting for the Rangers and mourning the Astros. But we're not going to spend a lot of time, talking sports or politics for sure. We're going to talk fish biology. So that's my focus. But, I don't want you to feel like this is drudgery or that, I'm being a taskmaster too much. I want you to have a good time, but I really want you to get into it. Engage is the word I like to use. And try to understand the things that I can tell you and teach you. There are a lot of things I can't do for you. But there are some things I can, and it behooves you to take advantage of that and try to get as much from me as you can. So, here is the course syllabus web page. And I want you to see who gets the credit down here at the bottom. Ray H. Camps, sitting right here with us today. Ray didn't do this web page, though. I think I just, stole your template from mariculture or something, Ray, that we did together and adopted it for fish biology. So, this is the place you go to get all the details about the course, and it's fairly well, it's up to date, it's organized, got a, picture of eco-fish that'll open up, scare you. You can see all the innards, all the blood vessels. No, not really. Those are connections in a Stella model inside. But, as I'll point out a little later, you don't have to worry about a lot of those connections. What you have to do is handle eco-fish like you would a real fish. Put it in the tank, apply the treatments that are specified, measure the responses that come back to you, and then interpret those responses analytically. The way you would if you were working with real fish. The difference is eco-fish is not gonna disappoint you very often. It's not gonna flop out of the tank. It's not gonna get fungus and die. Maybe it could be made to do that, but it hasn't been made to do that. Eco-fish is highly variable. All of the responses inside of eco-fish are what we call stochastic, meaning that they incorporate a level of error that we think is consistent with the reality. So that what you see when you look at the data that come out of eco-fish looks a whole heck of a lot like real data from real fish. So, once you're at that point, you're not missing much. But eco-fish doesn't make much of a fillet. So, that's just a picture for, grins, really. That doesn't do anything. It's just a picture. It's a GIF file. To really get eco-fish to do anything, you got to use software called Stella, which is the program in which eco-fish was programmed. We'll get all into that. I pointed out in the getting started email that if you haven't, you should take the tour. 4-part tour. It lasts 79 minutes, but it's worth the trip. The first part there is only about 10 or 15 minutes. All of these open up and play inside your browser. You don't have to have any software on your computer using Shockwave Flash. Why don't I do everything with shockwave flash? Because it's a pain in the somewhere to convert everything. You know, the production is a hassle. And then there's another big disadvantage that I'll get to later. So, you know, we got a journal that doesn't go anywhere anymore. We quit that thing because nobody cared about it. If you want to see the official syllabus, that's it. You know, it gives you all the nitty gritty. So here's the course. It's a 3-credit lecture, 3-credit lab, 4 credits total. I list as prerequisites natural history of the vertebrates or ichthyology, and 414, which is Dr. Relke's course, Lakes and Oceans, or an oceanography course, an introductory course in oceanography, or approval. And I don't think I've ever had anybody that I denied approval because they came to me and said, "Hey, I don't have this course, but I'm really determined to be successful in this course of yours." And I say, "Okay, we're going to do it together." You know, if you have the determination and the grit to do it, I got the determination to do it with you. And we're going to make it work. Text is Biology of Fishes by Carl Bond, 2nd edition. Very good book. An old fellow at Oregon State, excellent scientist. But it's not absolutely essential. You know, it's good background for people that want to read a textbook. So it's not required. You can probably pick up a copy at local bookstores, maybe half.com or someplace like that used. If I had to point you to a textbook, I guess it would be this one in my hand, which I'm going to hand out to the class locally, and I'm going to make it available to people who are distant, either in the course registered or as professional courtesy audits. And what this is the backbone of ecofish, which we will get to. And I'm going to start it around over here and just let people grab a copy. It's a pretty lengthy paper. Got a lot of authors, including Dr. Robert Vega. What it does is lay out the development of the core that is the virtual fish that we use as our subject in this course for virtual experiments. I got another bit of reading. You know, I don't ask you to do a lot of reading. Mostly, you know, I ask you to do a lot of thinking and a lot of calculating, but not a lot of reading. This is not a writing-intensive course. It's not a reading-intensive course. It's a thinking-intensive course. So, you know, this is a reference. It's not anything you need to sit in and read through. But you might want to, when you get into it, you know, you might decide, hey, you know, this is really my cup of tea, and I'm interested in this stuff, and I'm into the math of decision-making and all that. So, local section, we're going 11:10 to 12:25 on Tuesdays and Thursdays. We're on Tuesday, the 28th day of August now. And our lab is on Tuesday afternoons from 2 to 5 or whenever. And we probably won't normally be here much after 5. You may have to be here on your own or wherever you are long after that to get the work done. But, you know, at some point we all get tired and just leave. But the official time is 2 to 5:45 in this room, 110 Nagel, for local students. And for non-local students, it's wherever you are and whenever you are. You know, this is not something that's transmitted live. It's something that's done, captured, put up on the server, and then those people who are distant can download anytime afterwards. And what I'm doing now will be up and available probably by 3 o'clock this afternoon, and that's sort of the pattern. We could, you know, those of you who are hearing me instead of seeing me, we could have one-on-one or even group interactions live if we decide we need to, you know, using Skype. Or maybe even Centra, which is other software that we have access to. But normally I won't do that. So, you know, here's the grading scheme. It's a traditional 90, 80, 70. There are 2 exams in this course. One will be on the 11th of October, and that's fixed in concrete. And so is the final exam on the 7th of December. That's Pearl Harbor Day, isn't it? I hope that's not an omen. Anyhow, those are the 2 exams. The first exam is 25% of the total, and the final is 35%, not because the final is going to be much bigger, it's the same size, but because I want to give you a chance to learn from the first exam so that you don't have as much riding on it. In other words, the exams are equal, really, in terms of the content and the length and everything. But the final exam counts 10% more. So the total for lecture, what I call lecture, is 60%. And then the lab is 40%. And I guess if I had my way about it, I would reverse the 2. And lab would actually be worth more because you're going to do a lot more work in lab. And you're probably going to learn a lot more in lab. This is the best lab you've ever had or ever will have. I promise you. You know, you tell me after it's all over if that's not true. I remember when I sat where you sit, 40 years ago. And, you know, everything was lecture, and the labs were basically going through the motions, watching things break, watching things not work. And I swore to myself that I would eventually get to the point where I didn't have that, you know, where I didn't offer students that kind of disappointment. I didn't offer them the lesson that, hey, you know, lab is a waste of time. You know, it's... So I'm trying to make sure, in fact, I think I can promise you that this lab will be one that you will really take a lot out of if you give a lot into it. Anyhow, it's worth 400 points of this 1,000. And here's a little dichotomy between the undergraduate course 417 and the graduate course 617. There are only 5 real labs all semester. Each one takes a 2-week cycle. We'll get to that. And when we get done, there's a final seminar, sort of an expose, a grand finale presentation that everybody is expected to participate in. But there isn't any follow-up analysis or report generation for undergraduates. So that's why the undergraduates get 80 points on each of 5 labs, and the graduates only get 60 for each of those 5 and have to do a final project report, where I expect you to take what you've learned and move it a little bit further ahead. You know, modifying ecofish, doing an experiment that appeals to you. I'll help you. You know, we'll program together if we need to. So that's the difference between the graduate and the undergraduate courses at that point. Then I got some material down here about handouts and everything being being what? Copyrighted? Well, yeah, but, you know, feel free to hand it around. I mean, things that I generate, like the paper that I just handed out, you know, that's free for anybody for the taking. In fact, you know, I want you to. I want you to learn. I want you to pass it on. And but there are some things that are copyrighted by somebody else, and those things I've protected in the on the archive page. You'll see in a moment by having a password required, which I will give everybody when the time comes. There's the Aggie Honor Code at work. You know what that means is you need to work and do your own work. I'm sure everybody here is going to be committed to that. And then there's some things about disabilities. If I've got folks that have any and need some special consideration, I'm more than happy to accommodate. So read that. React to it. That's the prospectus or the official syllabus. Schedule events in 2 parts: lecture up above and laboratory down below. And you know, I used to put dates on these lectures, but I finally realized that was nonsense because I never kept to the schedule. So I finally just sort of started ordering them. The only one I'm sure about is this first one here, which is the 28th of August. And that's the introduction I'm giving now. And next time we'll start with the serious stuff having to do with the environment that fishes have to cope with. Ray will help me on that. He's a water guy, so he knows about that. Then we'll talk about, why fish are fish and what makes them different from the terrestrial animals that some of you may be more familiar with. The biology itself, per se. Starting with foods and feeding, and then circulation and excretion, respiration, some stuff on buoyancy, which is kind of a little special favorite topic of mine. Energy budgets, real important because energy budgets lead you to one of the main three emergent properties of individual animals that go on to contribute to the larger group, and that's growth. I see three emergent properties as being key for individual animals. There's actually four, but I'm going to neglect that last one. One of those is growth. But before that even is survival and mortality, the two sides of that coin. You got to live to grow. And then the third is distribution within the habitat movements that optimize environment, particularly. And then the fourth I'm thinking about, of course, is reproduction. But, most of what I'm going to deal with in here is going to have to do with juvenile fish. I'm going to be remiss intentionally in neglecting reproductive biology. Don't know a lot about it. So we're not going to have much to say about it. I may have a few topics right at the end about future generations for future environments, if you look down there at the bottom, and spawning migrations and those kinds of things. But up till the midterm, we're going to be dealing with general biology of fishes ending in growth. And then after the midterm, we're going to deal with how do you cope with environment that's changing. It's not always the same world. And you better have some ways to accommodate that. So that's what this section deals with, and particularly with physiological adjustments that animals make, you and I, as well as fish, to the variation of environment. And using things like photoperiod to anticipate the coming of future environment. It's going to get cold eventually, because it always has. At least it used to. I hope it, continues to. So, and then some stuff at the end here about behavior and learning, condition responses, behavioral regulation of environment, one of my very favorite topics. The movements that animals make to optimize environment. And then partitioning the environment, interactions. We're moving here from ecology into synecology, so you can see this is just glossed over a little bit, but I feel some obligation to talk about things like competition, predation, cooperative arrangements. And then finally, as I said, a little bit on future generations for future environments. Okay, then we get to the heart and soul of the course, which is the laboratory part. It's designed to complement, well, I ought to say the lectures are designed to complement the lab. What I attempt to do in lecture is to give you the background that you need to really appreciate and engage in lab. First lab is on food processing, stomach evacuation, digesting, those kinds of things. And the pattern is the same for all the labs. We're going to start lab next Tuesday. We won't have lab this week. The first week of lab in each, the first session of each segment is some background, introduction, motivation, why we're doing this, and then actually doing it. Running the simulations, getting the data. And that's it. And then the second week we come back together, either literally or figuratively, metaphorically, and engage in making sense of the data we collected the first week. That's the analysis. And I've developed very well-organized, I started to say very constrained, and they are, suggestions for analysis of these experiments. And that's what you do. I call that the help session. And, or maybe analysis session would be better, but I do make an effort to provide help in the analysis. And then your reports due at the end of the 2-week cycle when we start the next one. So there, like I said, only 5 real do-it labs: food processing, respirometry, and metabolism. Toxicity bioassay, body temperature and heat exchange in fishes and why normal fish are poikilotherms and fish like tunas aren't. And then environmental preference and avoidance behavior and viral regulatory behavior, I call it. And then the final lab is one where I sort of pick apart ecofish with your help, because by then you really know quite a lot about it, even though we're not going to get inside and deal with the math at every stage, the structure of all the functional relationships. And I sort of use that to introduce the idea of simulating growth as one big emergent property. There won't be any help session on that unless people need it, but there will be a required report due from the graduate students in the course, both local and distant, on the 29th of November. And then we're done, so we don't do any lab work after that. I want people to get done with lab and be able to focus on their other obligations that they have in other courses at the end of the semester. So, I had a thought about this, and I forget what the thought was now. Maybe it'll come back to me. You know, one of the things you're going to realize is you're dealing with an old guy, and old people tend to lose track of what they're thinking and saying. And if you notice that I'm off track, I expect you to say, "Hey, Dr. Neal, what are you talking about? You know, that's not making any sense in the context of what you were just saying." But I'll try to do the best I can to stay on topic. So that's lab. And what I said was that lab is really important. Oh, I know what I was going to say, and that was that back when Ray Kemps was involved in the lab, we did these experiments, the same ones with real fish. We tried. But we had, you know, a paucity of equipment, and the equipment we had normally didn't work. Of course, today I had computer troubles right before class. And, you know, the fish weren't healthy, and the students were kind of lackadaisical, and they were out in the hall reading the battalion. And so, you know, it was just like the labs that I grew up in as a student. But they worked sometimes, didn't they?
They worked for me.
They work if you really worked at it. And so what I did, and the reason this is such a good lab is because I pledged when I started developing this simulated approach to the lab, I pledged that there would be fidelity to the original exercises, that I would do exactly the same things. I'd make ecofish do exactly the same things that real fish had to do, except ecofish would feel no pain. We'd have to feel its pain for it. We as people working on ecofish. And I think that I really had a lot of success making that happen. And that's why the lab is good. That's why it works, because it's faithful to the reality that we once did. But it works a whole lot better, especially if you're in Georgia or even Corpus or even over in the dorm, you know, here on campus and can't be here for lab. You know, it also is a lot easier to deal with the animal use committees that enforce animal welfare. And I'm sympathetic with some of that, you know. But it's hard to deal with animals alive and not abuse them to some extent. And that toxicity bioassay, Ray, that lab killed us. You know, we finally had to quit doing it because we kept getting asked, why are you having to kill all these fish? Just so people can watch them die. Well, the answer is because real fish do die, and we need to understand that. But I think you can do a lot of understanding without killing the real fish, because we have already killed a lot of real fish. That's the reality that's built into ecofish. All those actual experiments that we did, not just in lab here, obviously, but all over the last 50 years of science. Okay, so that's lab. I'm big on lab. What can I tell you? I got to get back to my PowerPoint and finish this thing up before we run out of time here. Wear out my welcome with you. I'll try not to keep people late because I know you got other classes, other commitments, and we'll probably finish it a little early today too. Here are my objectives, you know, and I've thought long and hard about these. These objectives are not just off the top of my head strings of words. You know, I've refined and refined and refined. I guess number one is to strengthen understanding on your part about fish's mechanistic adaptations to environment. And you got to have some understanding of fundamental biology to do that. But a lot of that you're going to come into the course already knowing. You know how gills work, probably, if you've had ichthyology. Help you systematize your knowledge that you have, that you are gathering from other sources. And, you know, I think the way I'm dealing with this and encouraging you and introducing you in some cases, reinforcing in other cases your interest or your understanding of simulation is a good way to do that, you know, because if it don't work, it don't work. You know, if you can't make the simulation model doing it, how in the world could you expect to understand the reality of the real world if you can't even simulate it? Well, that's tough to say, but that's the truth. And then finally, I want to, you know, I've got a lot of ego, and especially this year, I want to make sure that when you walk out of here, you come slap me on the shoulder and say, hey, that was the best experience I've had. And Ray, I want you to do that too, even though you've already had it, because it's a lot better now than when you did it, and I did it together. I've already been through the syllabus with you. We started this whole approach to simulation in 2000, about 5 or 6 years after Ray was with me. And I'll remember forever, I guess, the day I got the idea. It was standing on a little creek down in San Antonio, talking to a student in ag engineering who was working with us. And she said, you know, I don't want to come over into wildlife and learn that, but I'd really like to learn something about fish biology. And, you know, I really don't want to get, you know, a lot of fish slime on my hands. And besides that, I got all these required courses that are going to be. And so I thought to myself, you know, would it be possible to replace the live hands-on lab with a virtual approach? And so I started working on that. And that first year, you know, it was touch and go. I mean, I was up till 2 a.m. every night before lab, getting that lab ready to go. And it wasn't until after that year was over that it occurred to me that, hey, I could pull all these sectors and Stella around and put them together and make them look like a fish and call it ecofish. So that part was easy. By the way, that student never took the course. But a lot of other students have. I mean, as far away as Costa Rica and Belgium and Panama and Ecuador. I think that's pretty much the reach. As well as, you know, a lot of students around Texas and the U.S. I didn't get into the idea of archiving on the record until 2001, and that's when I started making things not just CDs, but downloadable files. And I started working on when people obviously were having so much trouble and we were worrying ourselves sick trying to keep everybody working ahead. I finally started pre-recording these guidance files that I call help files that take you through the lab step by step. And that's been a salvation for the whole program. That means each person can work at that person's own pace. They can backtrack if they miss something and play it again. And people that are distant, you know, they got the help they need right then and there on their computer. They don't have to call and try to connect, you know, with their TA. So these help files, I think you'll agree, are just phenomenal in what they can do to help you. You don't have to use them. You know, Ray didn't have them when he was back there TAing. You know, the students had to work from a handout. You'll have the handout. It's the same handout. The handout will show you what we did back in the good old days or the bad old days, and then it'll show you what you do differently now. But that's all we had back then. People were expected to do these analyses without the help of help. And even without the help of Excel. Now everything is Excel-based. Those original files were created with Excel 2003. We managed to hobble along in a crippled way with some translation files through Excel 2007, and then finally this year, when I decided this was it for me, I said my last effort is going to be to update everything. And so I spent this summer converting all these 2003 based help files into Excel 2010. And I think here in the room and most everywhere is going to be working probably in Excel 2010 now. So I'll put up the old and the new. You can work on either one, whichever you've got. Well, there's some other things. The EcoFish improvements. I keep adding to that. As recently as last year, I was still adding what I call added value to EcoFish so that you could extend the actual exercise into areas beyond that. Well, yeah, I'll do this, but okay. So audicology. That's what this is a graph or a little symbolic representation of. It says that the environment. And let me use the Control A. Does everybody know that little trick? If you ever give a PowerPoint show, Control A will keep your arrow always visible. Instead of letting it die on you, it dies. And then on Camtasia Capture, it's really frustrating because what you see is somebody going like this, shaking the mouse, trying to get their arrow to come back. But you can see it on the capture. They can't see it live. This way, I just remember to click on Control A, which makes and Control T, by the way, allows you to see your taskbar when you're in the presentation mode. So anyhow, environment drives everything, more or less. I mean, environment dictates physiology by transfers of three kinds of things that exist, and those are mass, energy, and information. And then the physiology of the organism operates in such a way as to modify the behavior of the organism, either just, in reflex type responses with just neuromuscular, or maybe it's central, maybe not, maybe it's endocrine, maybe not. But anyhow, some of that ends up as behavior. And there are two broad subsets of behavior. One of them Dr. Packard would focus on in ethology, and that's what I call behavior in place, sort of stereotypical kinds of things that animals do, like displace. And then there is enviroregulatory behavior, which is, in effect, moving around in the habitat to optimize the environmental situation. And that's what we'll focus on, is enviroregulatory movements that feed back to affect future environment. And so it's just a loop. And I've got one arrow here that has two heads. And that's real important in aquaculture. And that's the fact that the animals themselves can have an effect on their environment through excretory wastes and that sort of thing. Anybody that's ever tried to keep a heavy density of fish in an aquarium or a pond knows all about ammonia and stuff like that. We'll think about that too. This is a kind of a model. This is sort of the simplest type of model. I think already you can see that it's useful in terms of representing a real complex situation in a fairly simple way. Helps you get the cause and effect relationship sorted out in your head, and warns you that maybe some of those aren't as simple as you first thought. What you thought was a cause is actually an effect, and vice versa, or that there are sequences of cause and effect, and it's pretty hard to trace it sometimes. One way of modeling is the way I just showed you, with a concept that you can put up on a monitor and show on a screen, and the other way is a physical model. And I guess maybe physical models are probably older and more familiar. Everybody remembers from their childhood, dolls and model planes and trains, and those are all physical models. And as recently as the 1960s and 70s, a physical model of the Mississippi watershed near Jackson, Mississippi, was more useful in predicting river stage downstream than any statistical or computer-based model. So, physical models are not just toys. They're useful things. I mean, of course, people who build cars and planes understand that very well. It's hard to capture all the complexity in airfoils and streamlining in models that are conceptual, even good simulation models. You know, you almost need to build a mock-up, put it in a wind tunnel, and see. But simulation modeling is cheap, relatively. You know, you don't have to build a structure. You don't have to go to the place. You can do it anywhere on the computer. And, you know, my metaphor's a little overworked there. Teeth that chew on tough problems, I guess. But that's what it does for you. Models are not reality, and I try never to forget that. They're just tools for helping understand some aspects of reality. And to the extent they're useful, then they're useful. Albert Einstein, he actually didn't say that. He said explanation should be made as simple as possible, but no simpler. And I would paraphrase that to say models should be made as simple as possible, but no simpler. In other words, a model's got to have enough integrity and enough robustness in it to be useful, or it's not, you know, it's just a toy. And I hope Ecofish has achieved that measure of being not too simple. And then I guess it's obvious that good models enable safe and reliable, well, maybe certainly safe, maybe reliable evaluation of what-if scenarios. You know, you wouldn't want to do things that you wouldn't want to find out what if by going and actually doing it. It might be a real expensive proposition, and it might be irreversible. Let's don't melt the polar ice sheet, you know, to find out what would happen, even if we could. I guess there is a downside to that, though. And the downside comes back to models are tools and not solutions. And that is that if you got a model and you're so confident that it's right, and it isn't, it's always wrong, you know, somewhere down the way. That's part of the scientific idea, the scientific method. Then it may make you overconfident. It may make you think you understand the world, so you can go out and do whatever it is your model said you could do, but that could be a big mistake. So you got to be careful not to overstep, and that's a risk. Well, you've already seen Ecofish with its scales off. And when you look at that paper that is in front of those of you in the class and is going to be in front of those at a distance. By the way, those that are listening to this, I would want in your initial email, could you give me a good mailing address? And I'll mail you a copy. This sector right here and this sector are the two core parts of the model that's described in this paper. Everything else is layered on to make it work in this lab. And a lot of it is to do with the controlling of environment, which is this part over here. Presenting the environmental treatments to Ecofish, and then all these things around are input-output devices where you can set the values of the treatment variables, and then you can read the gauges or read the tables to get the outputs. So Ecofish is more than a fish. You know, it's the whole experiment. It's the virtual experiment. You won't have to look at that in that form. You know, mostly what you'll see is this form where all you're looking at is just the sector that's important. And I think that in the mouth region there is appropriate, is the sector that's right for Lab 1, where we're dealing with input feeding and food processing. You know, I want you to take that tour so you can find out what you're in for. You can do the tour in one of two ways. You can either do it from the flash files that are the links that I showed you there on the syllabus, Tour 1, 2, 3, 4, or you can do it from the AVI versions that are on the course syllabus. And let me go there. I don't think we've been to the syllabus today, and I meant to show you that. Did I show you? I didn't show you this. You may have seen it. You know, if you read my email and you clicked on the links, you would have seen this. You know, this lays out all the stuff. It tells you, you know, stuff that's in that opening email that you got to have this codec, this little thing called a TSCC codec to decode the audio, to decode the image parts of the Camtasia files. Without that, all you get is sound, no light. And you also would maybe want to use IrfanView, and you can play the Getting Started flash file right here. Click on that. It'll download, play right in your browser. Runs about half an hour. It's all the secret stuff that you need to know about loading the software and using it. And some of the advantages of OrphanView. There's also a PowerPoint with it, the PowerPoint I'm working from, just so you'll have the links so you can click on them and not have to type them in or copy them, because you can't get that out of the Camtasia playback. You can only get it by going to the PowerPoint file. OrphanView promo. This is a tribute to the main virtue of OrphanView as a free player. It's a really good graphics viewer for still images like JPEGs, CGMs, whatever. It's also a great device for playing back AVI files. And the reason it's so great is, as I explained in my Getting Started video, is that you can play back the files at speeded up rates. And, you know, I draw, and so, you know, you can speed me up. You can turn me into a Yankee first and then to a Donald Duck, you know, if you want. And I would recommend it, because what it does is compress time. You know, you can do an hour's worth of stuff in 40 minutes, 50 minutes, depending on how much speed you can stand. Here's the bad news. As I explained in the Getting Started, it only works in Windows XP and earlier, Ray. Does not work in Windows 7. The guy that invented OrphanView and I couldn't make it work. We tried every codec known. We couldn't make it work. So I would appreciate very much anybody out there that's a whiz on this sort of thing coming up with a player that will play back AVI files in a speeded up way and keep the synchrony between the audio and the image. You can play them back faster than normal speed with Windows Media Player. But after about 5 minutes, the image and the audio get out of sync. And you talk about frustrating to try to follow something in detail when the mouse is going around doing things that you've already heard about 5 minutes earlier, or 5 seconds even. So that's the bad news, you know. And I don't know what these computers have on them in here. I hope it's Windows XP. I hope you've got XP or access to it. Or Windows 98 works great too. But Windows 7 does not. Go figure. New better than used, right? Well, maybe not really. Not for everything. You might want to click on that sample exam to see what you're in for there on the 6th of October. Lays out the whole deal, you know. Yours will look just like that. Maybe the questions will be a little different. You know, here's the format that we're going to have. There's today's presentation. You won't get anything now because it's not up there yet, but it will be by 3 o'clock. You would get the black and white version of this PowerPoint show that I'm showing right here, right now. And I do that just because it takes less printer ink and so forth, you know, file size to do the black and white. This is it, though. Same thing, same content. So these AVIs, they're dump downloads, as I explained in my Getting Started, meaning that, you know, you can save them to your hard drive. You'll always have them. Whenever you need them, you can click on them and open them back up and play them again. They're not like streaming video that, you know, once you close your browser, it's gone. Not even Flash, you know, it's gone when you close it, unless I give you all the parts of the Flash setup. So that's the reason I use AVI, because I want people to have maximum opportunity. And what this means for distant people, or for you, is that if you're doing this at home, or doing the lab at home, let's say, you don't have to be in constant connection with the internet. You can download the files, go away to the woods, and play them back at your, you know, at your convenience. So that's a real advantage. This is the, you know, first week of class for lecture, just to give you the, and we'll just build these files down as we add them. Here's the first lab and some preliminary stuff up here. This lab expectations, you know, I need to get Donovan and Ashley together and let them decide what they expect of people in the way of reports. Probably be about the same thing we expected before. There's a sample abstract. You're going to be asked to The only thing you write in the course is the abstract for the lab. A lab, sort of the abstract like you were doing a scientific manuscript, you just do an abstract. Help for 2007, but I think most of you are going to want to run the help files that are 2010, and those are these. See, I got both of them there. Help A and B for Lab 1, 2003, and there's 2010, Excel. And then there's this extension here about some other stuff. So that's the way. And by the way, just for people that really want to look ahead, there's the whole archive. I don't keep secrets. Here's the whole archive from last year. And there's all the lecture, and there's all the lab. So you can see this anytime. I think I'm going to stop at this point and not overstay my time any more than I already have. I'll ask anybody that has a concern or questions to hang around after and ask me, or follow me to my office in 212, and we'll be good to go. Okay, I'm going to shut down the recorder.